Okay, in this video we're going to simplify some trig expressions. A couple of tips before we go into it. I've copied our identity sheet right here above it off the formula sheet. My advice for you is turn anything that you can into sines and cosines. Most of the time it's easier to work with. We don't have to, but a lot of times it's easier to work with sines and cosines. You can turn secants and cosecants into sines and cosines using reciprocal. We can turn tangents into sines and cosines using your quotient identity or the cotangent. Since it's the reciprocal of tangent, we can turn it into sines and cosines as well. If you're ever dealing with squareds, something squareds, and especially if there's something squared mixed with ones, that's when your Pythagorean identities come into play. So let me show you what I mean by simplifying these. So again, take my advice, turn everything into sines and cosines. Now let me give you a little bit of a warning. A lot of times I'll leave the angle off as I clean these up. So tangent, we know from the quotient identity, is sine over cosine. We're multiplying that times cosine. When you're multiplying fractions, remember that you can cross cancel, so we end up with just plain sine. And that's what we mean by simplifying expressions. Each of these have multiple ways of working it, so just because you don't work it the exact same way, but if you get the same answer, it's fine. The next what I see here is two things on top, separated by a plus sign, and they're both being divided by tangent, so that's distributive property. I'm going to split that up, and I'm going to write this tan over tan plus cotan over tan. Tan over tan, anything divided by itself is 1. And again, I'm going back to, we're going to turn everything into sines and cosines. Cotangent is cosine over sine. Divided by tangent is sine over cosine. To divide two fractions, we flip and multiply. So that's going to give us, I'm going to come over to the side and do that. That's going to be cosine over sine. When I flip, it becomes cosine over sine as well. So that's going to be cosine squared on top. Anything times itself is squared. Cosine squared over sine squared. And again, that's what this stuff is equal to. Cosine over sine, I'm actually going to turn that back into, I think it's going to be an easy way. Going to turn that back into cotangent. But since they are squared, since they're both squared, that's going to be a cotangent squared. So 1 plus cotangent squared. Now here's why I did that. I said a while ago that if you ever have squareds mixed with ones, that's normally one of your Pythagorean identities. And you can find the 1 plus cotangent squared actually right here. 1 plus cotangent squared is equal to cosecant squared, and I'm going to throw that angle back in there, and there's your answer. Next one, I'm going to go ahead and multiply these out. You'll see why in just a second. We do have conjugates. So to multiply conjugates, first times first is 1. Negative cosine times cosine will be cosine squared. Now let me tell you something else that's true about these identities. These aren't the only identities we have. You can actually manipulate these identities to find other identities. What I mean by that is we can move these terms from the left side to the right side or from the right side to the left side to create other identities. And that's what I'm going to do here. We'll take sine squared plus cosine squared equals 1. I'm going to move plus cosine squared to the other side. And I now have sine squared equals 1 minus cosine squared. And you see that right side now matches what I have. And since I say 1 minus cosine squared is equal to sine squared, I can now replace that with sine squared. And that's going to be my final answer. You might be questioning, when do I stop? How do I know I'm finished? Get it as clean as you can make it look, and you're finished. Next one, you can do a couple of things here. Since we've not done it yet, I'll show you that you can factor these expressions. I have a minus sign. Both of these expressions have a cosine squared. So I'm going to factor out a cosine squared. Here I'm left with 1, and here I'm left with minus cosine squared. 1 minus cosine squared I actually just used. It was right there. So now I have cosecant squared times sine squared. I'm going to turn my cosecant squared into sine stuff by doing, that's the reciprocal of 1 over sine. So cosecant squared is 1 over sine squared, and I'm multiplying by sine squared. Those will cancel. Leaves me with a final answer of 1. Next one, you can find common denominators. Everything that is legal in algebra is also legal when you're dealing with trig expressions. My common denominator will actually be conjugates. So my first term has a 1 minus cosine already, but it's missing a 1 plus cosine. So I'm going to multiply top and bottom by 1 plus cosine. My second expression has a 1 plus cosine, but it's missing its 1 minus cosine. So now I have common denominators. I made the bottoms the same. On top, I'm going to clean it up. I have 1 times both of these will be 1 plus cosine, plus 1 times both of these will be 1 minus cosine, all over. Now I'm going to go ahead, you don't have to, but I'm going to go ahead and multiply those bottoms together since they are conjugates. And you see that we actually have this exact same issue up here in number 3. We already know what that's equal to. And I'm going to, instead of going through these steps that I went through on number 3, I'm just going to go ahead and put the bottom is equal to sine squared. Plus cosine minus cosine cancels. You're left with 2 over sine squared. Now, anytime you have reciprocals, like 1 over sine is cosecant, 1 over secant is cosine, and so on and so forth, what you can do is anytime you're moving an expression from bottom to top, so like notice up here when we have sine on bottom, let me find it. When we have sine on bottom, if we move that to the top, it becomes cosecant. If we have secant on bottom, move it to the top, it becomes cosine. Have cosine on the bottom, move it to the top, it becomes secant. So it pretty much becomes its brother when you move it. So I'm going to rewrite this as 2 sine squared, or you can think of it like this. You can flip and multiply and do all sorts of things. Sine squared when brought to the top becomes cosecant. So sine squared will now be cosecant squared. Put your angle back in there and you're finished. All right, last one. Again, there's several different ways you can work these. You could turn these into sines and cosines. You could turn this into a cosine. You could deal with those. That's one way of working it. The way I'm going to work it is, again, I'm going to find common denominators. Tangent is my only bottom, so I need to make this a tangent as well. So I'm going to multiply bottom by tangent. And when I multiply top by tangent, it becomes tangent squared. I now have tan squared minus secant squared all over tan. Tan squared minus secant squared, you've got lots of squareds there. So let's go back up and check our Pythagorean. Here's one that deals with tan squared and secant squareds. I'm going to have to manipulate it a little bit. I'm going to take my secant squared and move it over here. Since it's positive, it becomes negative. I'm going to take my 1 and move it over here. Since it's positive, it becomes negative. Tan squared stays put. Tan squared, when you move the plus secant squared, it becomes minus secant squared. When you move the positive 1, it becomes negative 1. And that tells you that tan squared minus secant squared is equal to negative 1. So we now have equals negative 1 over tan. Again, remember what I told you a while ago, the inverse of tan is his brother, which is cotan. If you bring something across a fraction bar, if you bring it to the top, it becomes his brother. So we now have negative 1 times the cotangent of theta. There's your final answer.